Hey, everybody, welcome back to the Your Project Shepherd podcast. As we say every time, a successful project has four key components that are demonstrated by this simple childlike drawing of a house. The foundation is proper planning. The left wall is your team, the right wall is communication, and the roof that protects it all is proper execution. Have all four of these components in place, and your project is going to succeed. And joining me again today is repeat offender Toner Kersting.
That's right.
And semi-season, whatever this is, 3 co-host.
That's right.
And so in this current season, we've been talking about building performance failures. We're touching on some different aspects of how things go wrong with building performance. And today I wanted to talk about the building envelope, which is a term that gets thrown around there. I think a lot of people don't know what that is, but I think most of the problems that you and I see in consulting, most of the failures that we see are related to the building envelope.
A majority of them are related to building envelope, including internal pieces like the AC system. We can say that the AC system is what's creating the problem, and an AC system is a reactionary tool. It reacts to what is presented to it, and the presentation comes through that envelope.
Yeah, and the AC system also, just with the pressures that it creates when it operates, kind of interact with the building envelope.
Exactly right. I mean, it is the delineation between indoor and outdoor climate. And that's what we're trying to design for in balance of a building performance design is how do we manage the indoor and outdoor climate relation? And that device or that assembly is the envelope. But I think a lot of people think it's just the walls, and it's not just the walls. It's the walls, it's the roof, it's the foundation. It's the instruments in between it, the windows, the doors. It's those things that transgress it. Exhaust fans, flue pipes, plumbing stacks. It's something that we need to design as a system, but we also know we're going to punch a whole bunch of holes in it that have to be there. So it's a really complicated assembly, and one that takes a lot of thought and effort.
A simple definition of the building envelope, or as simple as we can make it, right?
Sure.
A simple definition is what?
Yeah, I think it's important to understand that there's two sides to this envelope. One is the drainage plane, and that is the exterior side. And I say this goes from the very, very far exterior edge of the cladding. So let's just talk wall assembly, because that's easy for people to remember. So a brick wall, the drainage plane is the outside of that brick cladding. So water, rain hits it, it's going to drain down. But that cladding is going to absorb moisture, whether it be siding, brick, stucco. I don't care if you put rabbits on the outside, it's going to absorb some moisture. So then right behind it is the physical drainage plane, or also known as the capillary break. And that's where that moisture that moves through it is going to condense and drain out of the walls. Classic example is the weep holes that we see at the bottom of brick walls, which we can get into a whole conversation of how weep holes don't work unless you design them properly. And we design weep holes properly. A good proper weep hole is one that's going to be horizontal, not vertical. And I can explain all that. Then you start to have your sheathing assembly, what we're building against. And that's going to be a lot of people will see the zip wall referenced in that. But then how we seal those elements that come through it. That's where we start to use a lot of continuous insulation, especially in our design methodology, because we're trying to manage vapor. Then you actually finally get to the stud frame. Oh my gosh, we actually have the stud walls now. And that is important because those studs are nailed to the outside and nailed to the inside. So that is a really big bridge element. Then you have the insulation. And so many people think insulation is just R value. I believe R value is actually the lowest quotient to take under consideration. We want to understand how it changes the pressure dynamics, what grade barrier of air it is. Is installation methodology. Is it something that's going to contribute to vapor drive or lessen vapor drive? Then you finally get to the inside of the cladding. So finally, sheetrock is most common. It could be plaster in some cases. But then that's called the dissipation plane. Water vapor will move through that. We dissipate the interior. So then it goes all the way to the outside edge of whatever you're finishing that with. Paint, painted paneling, the inside of cabinets. And cabinets is actually the face of the door. So your building envelope of your wall goes from the outside leading edge of the cladding to the inside leading edge of the cladding. And the complexity of those materials in between there is huge. And how you maintain its integrity or accept its performance criteria, it's a lot of thought and effort.
Yeah. So this kind of the building envelope term and building performance in general, but building envelope term. I mean, it's always been around, right? But over the last, let's say, 10 or 15
Yep.
years, it's really come into the conversation a lot more. Um, why is that? And like, why is it so much more important today than it was 20, 30 years? And is it more important today? But why is the conversation around that more now than it was years ago?
Sure. And that conversation really started in about 2009. That's when energy code really came into play. It was accepted by the state of Texas. And energy code speaks to envelope pressure, but they're thinking about the pressure differential, the amount of leakage. So now a new house under 2021 IECC, International Energy Conservation Code, is 3% envelope leakage. A house built in 1992, and the reason why I say 1992 is that's a reference house that we already have, had an average leakage rate of 31%.
Wow.
So huge difference. And what that energy code didn't realize is in their effort to just lower utility bills, because energy efficiency all cares about utility bills, it changed the performance criteria greatly because that envelope pressure changed the pressurization delta from inside to outside. And it's not that houses should be leaky or they should be tight. It's that you should acknowledge that pressure dynamic, because in almost all scientific equations, when you add pressure, increase or decrease, it changes the thermodynamic principles. So striking that balance between indoor and outdoor climate is directly related to the pressure dynamic. And that pressure dynamic is generated by the energy code. So the reason why we talk about it more now is because of the introduction of energy code in 2009.
Yeah. I remember back when I first started, an older builder that I knew used to tell me, the houses built when I was growing up, when I was learning back in the 50s and 60s, they breathed. We didn't have all these problems that we have today, and that's the way I'm still going to build them now.
Mhm.
Well, that was up until
That time.
the mid early 2000 to 2010. And that's when he kind of phased out of building.
Yeah.
I think maybe he saw the writing on the wall, and he didn't want to be forced to do all these new techniques. But I mean, there's some truth to that. Back in the 20s, 30s, 40s, 50s, 60s, the structures were not tight. In general, they breathe, and you didn't see as many of the moisture problems, the mold problems that we have today.
And that, I don't know if I necessarily agree with that. And that's not because people who are making that statement are incorrect. It's that they don't have any, they've never gone looking for those dynamics. We've spent almost 15 years going to older structures and understanding how they performed then and they perform now. Additionally, speaking to previous owners, especially a lot of older builders who had a higher level of performance knowledge back in the 80s, the 50s, the 60s. Houses weren't awesome. That's a big case of old timer syndrome right there,
Yeah.
right? It was better back then. Yeah, I don't know if it was better back then, because we still had houses that were sick, right? I'm dealing with issues from wallpaper. Now, they dealt with issues in wallpaper in the 60s. So that didn't change. I can specifically go to any older structure and explain why you didn't have problems at one time and it had problems at now.
Right.
And the big thing to remember is that it wasn't that houses were leakier. Houses were leakier, but that leakage rate was available to go to the inside or the outside.
Right.
So when we installed AC systems and we didn't do our math correctly, which math wasn't required on air conditioning in Houston until 2018. So no math, zero math. And it's really required now, but the city does an extremely poor job of validating that math is actually being accomplished. They used to have really, really, really large AC systems. So that created a positive, and they ran all the time because the houses were inefficient. So the heat load was ever present, regardless of the owners. So inefficient houses made AC systems run all the time. The AC systems were really, really large. So it created a positive pressure system running almost 100% of the time. And if you have a positive pressure house with positive leakage, and this is really important because positive pressure in a house that does not have positive leakage, namely a new house, actually creates a ton of problems.
Right.
Positive pressure or positive leakage means we're blowing more air out than can come in. And a great example of this is if you go to a 1970s house and they have the original windows and you look at the white painted trim and there's a line of mold around the white painted trim where it meets the window, that's because the positive leakage is pushing air through that and it's condensing on the caulking outside.
Mm-hmm.
That's showing me that this house is performing due to positive pressure and positive leakage.
Right.
So I can answer that question anytime. I try to avoid people, and it comes up to us all the time when we give speeches. Well, I don't have this problem in my house. I'm like, you know what? Let me come look at your house. And there's no two houses that are ever the same. There's no such thing as two houses the same.
I think what I was getting at was really those houses back then oftentimes tended to dry more easily.
They tended to not get wet due to the pressurization differences too.
Right.
And our rate of humidity was a lot lower. Our later overnight humidity, our amount of water per rain event was a fraction of this. But also our parents had lower expectations than we do.
Yeah.
We're so spoiled.
They didn't keep the AC at 70. They were happy with it. I mean, my dad would freak out if the AC was at 70, 76 or whatever. Because he didn't grow up with air conditioning.
Yeah.
He grew up with a whole house fan in the hallway. Right. And actually my wife in the mountains in North Carolina, she grew up without air conditioning too.
Mm-hmm.
Right.
Yep.
And so I think people that grew up without it maybe have they're less spoiled than I am.
Most definitely. And even the materials that we were utilizing had a higher resiliency factor, right? Stain grade wood, which was predominant up until the early 80s, it hides moisture damage because you don't see it materialize on the surface on a white painted surface.
Right.
So those things were still present. We just didn't see it. Our bathrooms had a lot of vinyl wallpaper on them. And that vinyl used to stream down it, and it does just like it does now. But homeowners didn't really care about it. They didn't see that as I should sue the builder over it. We were a lot less litigious too.
And like in my neighborhood, which was in Southwest Houston, which was built in the 1950s, a lot of mid-century modern architecture.
Mm-hmm.
A lot of those houses also had some nice big overhangs.
Yeah, they did
around the perimeter, and and having a wide overhang on your eaves,
it's huge.
Helps so much with keeping that wall assembly dry.
And landscape wise, we used to run bushes around our entire structure. And those bushes used to take the radiant load instead of the wall taking the radiant load. And we've learned that through doing forensic projects where they re-landscaped, and all of a sudden we have a really, really hot room because that landscaping, that old big ficus tree was covering up all the heat from hitting the walls.
Well, and to add on to that, back then, not everyone had a sprinkler system in their yard too. And so now we see a lot of cases where the sprinkler system is actually wetting the wall. Mm-hmm. That the heads are improperly positioned in the bed, or maybe they're turned and they're spraying on the wall. And so you see a lot of issues where that brick or that stucco or whatever is just staying wet all the time.
Now, I loved when I was a kid, my parents had that tractor sprinkler that you used to put on the hose and it would walk its way down the hose. I thought that was absolutely magical as a kid. I did not understand how that worked.
We never had one of those. We always had that, the ones that turned around, and it was my job to go out and pick the spike up and move it to a new spot and make sure the whole yard was getting watered. Yep.
I remember my dad leaving it on overnight, the big waterfall one, and walking out and just flooding the whole yard but only half the yard. So, yeah.
And then he's mad about the water bill.
Yep. They cared about those kind of things, but energy was cheap, man. I mean, it was part of the, there was a time in the 50s that the higher your electric bill was, it was like, it was a bragging rights. Oh yeah, I'm burning it up. Look, I'm so successful, right? That's not the case now. I mean, Jimmy Carter is really the person who started the energy efficiency push, but he still wasn't trying to get metrics down on those utility bills. So.
Yeah. So why do so many builders today have problems getting these details right? What's causing all the the issues that you and I see all the time? We tend to get the same kinds of calls over and over. Why are builders struggling with this?
Well, it's really a struggle from the homeowner side. Now, let's take spec builders out of this, right? Spec builders, I think we had this conversation when we had Greg Swedberg and Matt from Anvil here. Spec builders have problems because anything that's under the wall that you can't see, they're not going to put any value in it because they want to sell a house. And I'll repeat this to everybody again. If you're buying a spec home, it is likely you're buying a painted pig, right? You're going to just keep my number. We'll talk to you later on. But normally so many decisions have happened prior to the builder showing up. They're reacting to what has been presented to them. So trying to come in and reinstitute a design process is not really a good thing to do. It's very difficult to say, hey, let's stop and reset this. So we do work with a lot of builders. That is a complicated conversation. We're very good at having it, but lots of times builders are doing that. So that if the homeowner says, I'm not interested in the building performance design, they're washing their hands of the performance issues. That won't keep them from getting sued. It'll keep them from losing the lawsuit. It's a design stage issue. We don't require architecture here. But I'll go to my next closest city, which is going to be Miami, right? Miami's hot and nasty and wet and just like Houston.
Yep.
So why do I not have the same rate of issues in Miami that I do here? So I saddled up and I went to Miami for a couple of days, made some appointments, and when looked at houses. First off, totally different build style, CMU block assemblies, not a lot of stick frame, different windstorm standards, state licenses for the builders, and architecture is required on any house greater than 1,100 square feet.
Wow.
So every homeowner has to go through an architect. So the design, good design happens at the design stage. Trying to do good design at the build stage is challenging. It takes a really distinct builder and a very confident process to do that. And they're going to be more expensive, not because they're making the house more expensive, but because they're fully realizing the scope. So then homeowners are still, especially Houston, we have a lot of young money here, folks who have not gone through this process before. Fast money tends to lead to fast conversations and fast decisions. And also the average homeownership is only 5.5 years here. And there's always another 50 houses available to go buy. We have tons of clients who just bail over and over and over. And that's pretty much the entire island of Galveston. Oh, my house is freaking horrible. I'm just going to bail and go buy another one. And there's 19 people waiting to buy it right behind them.
I think that especially when budgets are tight and people are looking at places to trim, some of the better performing products are some of the first things to get cut.
Yep.
So, let's not do the Zip R. Let's just go back to OSB and Tyvek.
Yep.
Or whatever. Let's substitute materials to get the cost down on this, because we have to do that to hit that price point.
And that's unfortunate. And many cases, I'll be the velvet hammer in that conversation. And I have one going on in Westview right now. Homeowner's very, very dedicated in their original conversation to building performance. He has a daughter with a mycotoxin sensitivity. This is absolute. This is great. We want to do it. Send him a proposal. He comes back. He says, well, isn't my house going to get more expensive now? And I'm like, but you just spent 2.5 hours explaining how important this is. And we validated everything that we're saying. I can show you the results when we don't do it. He's like, yeah, but I don't know if I can afford it. And I was like, well, aren't you about to do a $250,000 water reclamation system? I was like, how about you don't do that? Well, I really want that. So
would you rather have that or your daughter being healthy?
It's flabbergasting that they choose to spend it on things that, despite the obviousness of this need, it is still under the walls. And I had to explain to them everything that we touch in terms of building performance, especially this house is a very complicated envelope, is permanent. Everything else, including that water reclamation system, will get thrown away.
Yeah. So, I mean, what's the cost delta there? Are you saving $20,000 by not doing this? That's going to help keep your daughter healthy?
Yeah.
How about shave $20,000 off the appliance package?
Exactly.
Or don't do X finish in another area that you can always do later, and that's a depreciating item too.
Exactly.
Right.
Yep.
And we've talked about this before. Like, go ahead and spend the money and do the things now that are going to be long term.
Yep.
Long term health for your family, and maybe put off the the Sub-Zero.
Exactly. How many times have you told clients to do carpet on the second floor? Hey, just carpet your second floor for right now. Right.
Yeah.
Stop at the staircase.
Yeah.
And cut your doors up high enough, and don't set everything down so low so that when you come back with the wood floor later on, and it's taller, you don't have to lift things.
Right.
Just cut yourself some slack.
But I have to have hardwoods.
I have to have hardwoods. That's right. I won't have a sealed attic assembly. I'll have wet air dissipating through fiberglass insulation, rat and roach poop on top of where my kids sleep. But I want hardwood floors, right? That's crazy. But when it fails to a T, every homeowner fully expected that house would perform at a level that they did not pay for.
Right.
And that's what they'll sue you for. So,
yep. Like we've said many times on here, you get what you bought.
You get what you bought. And we had to explain that to people over and over and over again. So,
yeah, I was having this conversation. Who was I talking to on the last podcast? Alan Griffin.
Yeah.
Alan and I were talking yesterday, and we were talking about
speculative homes.
Yeah, and just people expecting that they're gonna to spend this money and they're gonna get something that they never paid for.
Yeah, and in that line of conversation, they can't look behind the walls, right? They can't go look in an AC system and see if it's been designed well or installed well. They don't know the performance criteria and what would the result of what they're buying. So their argument is going to be, well, had I known and someone had explained it to me and the importance, but I can prove every single day that I explain the importance to that probably 3 times a day to new people. And I'd like to think we have a 100% close rate, and we don't. But if they don't, at least our builders are going to have some protection behind them. We'll let the homeowners make their own bad decisions instead of the builder making their own bad decisions.
Are there alternative products, or are there products that a lot of people don't use, or new products coming to the market that people should be considering to use in place of traditional framing techniques, traditional building techniques that are going to get them ahead of the game as far as the building envelope performance goes?
Most definitely. And I think there's, let's talk about ICF. That's probably the easiest one. We've had a resurgence in this product, especially when we had the commodity issues and pricing going up and everyone was looking for alternatives to framed wall assemblies. I know that later on, we're going to have a conversation with Jeff Eric with Coastal ICF. So he'd be great to really dive into the details of that, because it's not as easy as it could sound. You really do need to have a specialization in it. But ICF is insulated concrete form. And the way I like to explain it is it's foam, concrete foam. So it's a foam form with steel in between it. You backfill it, and it's like a solid mass wall. So now instead of a building envelope being a disconnected envelope assembly like the one I explained earlier, thermal mass is one where everything is touching each other. The easiest thermal mass wall for people to imagine in their head is a CMU block, which CMU stands for
concrete masonry unit.
Oh, you won. Good. Okay. Concrete masonry unit, also known as architectural block, arc block. And up north, they call it arc block. They don't call it CMU for some reason.
Yeah. I would say most people think of it as just cinder block.
Cinder block. Yeah. If you take a CMU and you fill it, right, you don't leave the holes in the middle of it. That is a solid mass wall. So now when the outdoor environment and the indoor environment are disconnected by this, you will have some fluid movement of the heat, pressure, air, moisture. But typically the wall is so thick that it finds its place somewhere in between, where it finds an equal or a neutral buoyancy or neutral balance, and it will either maintain or move back to one direction, typically to the outside. That's not the case here because our deltas from inside to outside are so huge, right? That it still tends to come to the inside. So we have to do some additional things to the outside, like adding vapor barrier applications. The problem with doing vapor barriers on a CMU block is it's not a permanent application, and you're not going to see it again.
Mm-hmm.
So when it goes away in 10, 15 years, it's going to have a degradation factor that's going to increase with the age of the home. ICF doesn't. It has a poly on the outside, a polyistyrene on the outside, polyistyrene on the inside.
How thick is that? Like 2 inches on each side of the concrete?
Yeah, it's about an 11-inch wall when it's all said and done. It's about 2 1/4 inch on each side. We still have to paint a vapor barrier on the outside of it because that is not a complete vapor barrier, the poly on the outside. We need to use a vapor barrier that has some type of self-sealing characteristic to it, because we're going to punch holes through it for cladding and things we can't ever see it.
Yep.
I do like how thick that wall assembly is. It's going to also meet some really, really high windstorm standards. I mean, it's basically a bunker.
Yep. And noise too. It's so quiet.
Huge for noise. In fact, the key complaint that we have on the coast where we use this predominantly is they can't hear the waves. Right? I bought this house to hear the waves. I'm like, yeah, but your windows all have to meet windstorms, the hurricane standards, triple pane. The CMU, or excuse me, the ICF is far superior. And he's like, the only time I hear the waves is when I go in my attic.
Like, go sit on the porch, man.
Yeah, that's what you have this beautiful porch. And I'm like, you don't want to open up the doors and just let the house fill up with sea air. There's no more of that. In fact, there are times where we install air curtains to prevent that from happening. We've got a project in Rockport, which is weird because it's a coastal city where they don't require elevation. So the foundation of the home is only 4.5 feet above the water, the high tide.
That's crazy.
Why would you do that, right? But you can't go pop one up when all the other ones are not. So it's this weird kind of old code that still lets you do it. But she said that the rule is we're going to have parties here for about 60 people. We want all the doors wide open. It's going to basically create a dog trot going through it. But they have a massive art collection, watercolors on canvas. And so we're having to install air curtains in front of each art piece. So when they're having these parties inside and out, the humidity cannot make it to the art. And then we have to have a fast recovery dehumidification system. So when they close it up, we can actually remove all the humidity. It is monstrously difficult. But we have to design all this in a practical application, something that can actually be done.
Sounds expensive.
I don't think it'll get built.
Yeah.
I think that I'm kind of hoping it doesn't get built. But anyways.
Yeah, my grandmother's house in Cleveland, Texas, East Texas, it was built with 12-inch thick concrete walls back in the 1920s. And that is the coolest house in the summer. If as cool as it's going to be in East Texas in the summer,
probably cold in the wintertime
too. AC but those walls they really do a great job during the summer of keeping the house cool, and the AC system does not have to work that hard.
Yep, I went to high school in New Mexico, and we had some specialty buildings around the campus that were all adobe, like true hardcore adobe. Some of these were adobe houses from the late 1910s, 1915s. And there was no air conditioning in those spaces. So mind you, it's very, very dry, high desert kind of stuff. And they were always so comfortable. And I would always choose a desk next to the adobe because I was hot and I could put my hands on it and the adobe would suck the heat out of my body through my hands.
Mm-hmm.
So, it was pretty cool. That same thing with Saltillo. Saltillo actually makes you colder because the Saltillo floor sucks the heat out of your feet. So it's kind of cool.
Regional differences is something else that I wanted to touch on, because what works here in Houston or on the Gulf Coast is not going to work the same in other parts of the country. And that's a great example. In fact, I was going to mention I was in New Mexico at my uncle-in-law's, if that makes sense, at his house, my aunt's uncle's house. And they're in New Mexico, and I can't remember the city right now. They're in an adobe house, no AC. Adobe. With no AC, but they have a whole house swamp cooler.
Yeah.
Mounted on the roof, and they've got a giant fan in the living room that's just pulling air through the house. And even 105 outside, that house feels great on the inside.
It does. And but now, mind you, you step out in the sun and you start frying, right? And then we can talk about UV and all that kind of stuff. Santa Fe is one of my favorite places to go. We have about maybe 2 to 6 projects a year in that place. It is becoming a little more humid than they used to have. So some things are not reacting to it very well. But I love that. Give me a single environment climatically, and it's easier to design for. So even though we're saying Houston and the high humid climate zone is the most difficult, it's actually still a little easier because all we have is one thing. It's just the one thing we have is the worst.
Yeah.
Right. Same thing going all the way up north to northern Minnesota. All they have to worry about is keeping the house warm.
Right.
Everything else. And then the number of flies they get in the summertime, which is ridiculous because all the flies get born at the exact same time. Right. And there's a billion flies. Instead, we get our flies born across the entire year. So we have a lower ratio of flies. We had the same number of flies, just a longer duration of fly infestation. So,
So is kind of the southeast or kind of the south away from the Gulf Coast or maybe the Mid Atlantic where you've got hot summers and snow in the winter. Is that even harder to design for?
it is. Let's talk about your home state of North Carolina,
Yeah.
which is the next to Texas. That is the largest number of projects that we do. That had a pretty distinct 4-season climate but all 4 seasons were relatively minor, right? Or mild. Nothing was extreme. The problem is now those 4 seasons have really melded into about 3. The shoulder seasons have almost eliminated themselves. And they're colder in the wintertime than they used to be, but they're also more humid and hotter in the summertime.
Yep.
So it's their assemblies, their envelope that we're talking about today is one that's designed to allow for flexibility. But when we have an extreme environment, flexibility is not our friend. We are not flexible. So to come all the way back to the hot, humid climate zone, and I have people that say, why are we putting a vapor barrier on here? I want it to breathe. And I go, no, I want a zero perm structure. Zero. They're like, well, what if water gets into it? I'm like, it's going to go to the inside, guaranteed. And it's like, they're like, well, we should have something that can breathe to both ways. I'm like, no, you understand. When we get to water vapor, when we get to air tightness, 0 is the goal. Anything less than that's like half pregnant. It's like, I need to be full on pregnant. We're having this baby because otherwise we're going to be constantly dealing with those small inaccuracies. But even as I have not found ICF is probably the closest. Did you post the pictures from when we went to Trimco in Cleveland?
Yes.
So that new Dara ICF product, they came to us because they wanted to redesign the ICF for the coastal environment. Once again, building materials and products are not required to be redesigned per climate zone. But they're a pretty progressive company. So we took their product. I told them I want to have a 0 perm product, one that's rated to 22 mile an hour of air, of wind. I need it to be 98 degrees outside, 98% relative humidity outside, 72 degrees inside, 55% relative humidity. Those are the factors. But they actually had the facility where they can build that wall and recreate those environments. And then they were able to come up with a very specific additive that we had to put on the exterior of the ICF that makes it meet that standard. It's the only ICF in the United States built to Galveston Island standards.
Yeah.
And for everyone on the for everyone that's listening, everyone will be Galveston Island. That's just how it's going to be. Climate migration is flooding through humidity first, bulk water later. The last part of flooding is waves. The first part of flooding is humidity. And that's why in my, I just got a job in Cashiers, North Carolina.
Oh, wow.
Yeah. Kind of really cool town too. Mountain town. But that tends to be where the money is being spent right now in the Carolinas. A lot of very expensive structures and architects from all over the United States that are doing that work.
That's a lot of retirees.
And
so they're getting a lot of architecture from wherever they're currently living, designing stuff for their retirement home.
They're all Texans. That's how I'm getting it. They are Texans moving to the Carolinas, right? In fact, in Cashiers, North Carolina, they have there's a bar called Texas X. They have one of those it's the same people who have the bar in Kennebunk, Maine. It's basically a bar for Texans that move to that part of the United States, and they all go hang out and talk Texan to each other.
Wow.
In the middle of, there's that many Texans there, right? So
it's like Breckenridge, kind of.
It's like Breckenridge. That's exactly. It's like when everyone in Fredericksburg thinks that they're flooded by Houstonians. They think so. But the good thing is those homeowners, because they're previous clients of ours, know how important this is. So a lot of the architects and especially the builders, this is the first time they're ever hearing of any of this stuff. And as soon as we start a project, we normally get about half a dozen failure projects from that same builder and architect because they haven't figured out how to get beyond it. Yeah. And it's pretty difficult. It's not easy to figure that out. So
just to touch on Trimco again, Toner and I and Jeff, who we mentioned a second ago, who we're going to have on later to discuss ICFs, along with a couple of architects that we've had on the show, Bradley Hirtis, Jeremy McFarland, Matt Sneller.
Yep.
We all went up to Cleveland to the Tremco facility and checked out their materials testing lab and
It's really cool.
and their wall testing assembly lab and all this kind of stuff. There are not many companies out there who go through the rigorous testing that Tremco puts all their stuff through, and that was really impressive. We'll try to find a couple of photos of that and pop them into the.
We need to have
the video here.
Have them on when they're here in town next. That'd be really great because it is the material. That would be a great one in material science.
Yeah, Marcy
would be
get her on.
Awesome for it. The material science is important because that's what we're relying on in that envelope assembly. So understanding what the performance criteria is and reality of our microclimate is something that we've had to do on our own, but you do have companies like Tremco. I've had a bunch of other manufacturers approach us recently where they were happy to provide the same kind of data so we can feel comfortable utilizing their products. And just to remind everyone on this, we don't take any money from any manufacturers for any kind of conversation or specification on anything, including Tremco stuff.
Yeah, and that's something important to talk about too. Definitely not bashing anyone by saying this, but I think there's a lot of information out there on YouTube from some people who put out a lot of construction content, who you have to understand are sponsored by certain manufacturers, and they're putting out some really good general building science content, but it may not be specific to where you live.
Correct. So
somebody in Houston, Texas, or Austin, Texas, or Dallas, or wherever is not going to be giving you the necessarily the right information if you're in Minnesota.
Correct.
And so the techniques and the products that we use here are not going to be applicable everywhere. So I think that people have to be really careful at taking advice from, even us, from people on YouTube and podcasts. Yeah. The information that we're giving is not blanket for everywhere in the United States or the world.
Exactly.
So we try to always give that disclaimer, and we try to talk about some different regional differences. But it's just very important to note that something that you hear on a podcast or YouTube channel or whatever might not be right for where you live.
Exactly. And I'll give you a great example of that came up 2 days ago for us. So we get someone reached out through our website. They're building a new house in Fayetteville, Texas. So kind of in between here, Texas, or in between Houston
and Austin.
And everyone knows Houston's the center of Texas, right?
Like, that's okay. Right in the middle. Right smack dab in the middle of the state.
But the architect is from Amsterdam. It's a beautiful house. Like the type where I snap a picture of it and start texting it to my friends, like, this is going to be an awesome house. So I get on the phone with them, scheduled a phone call, did not realize that they were in Amsterdam at the time. I feel really bad for the time I called them. But they already have gone through a ton of performance criteria based on what they do in Amsterdam. And it's so unbelievably incorrect. And everything I'm hearing on this initial phone call, I don't want to turn to them and go, please stop. Like, stop what you're doing. Because we want to, now I feel like a responsibility to at least get onto a good conversation with the homeowner and them and explain what the process should be.
Yeah.
But this is, we're talking $400,000 for a set of plans.
True.
And they're designing it like it's sitting in the middle of Amsterdam. So how does an architect who charges that much money not think to adjust their performance criteria based on the reality of the microclimate in the middle of Texas?
Yeah.
I how much money do I have to pay somebody for them to take that under consideration? The envelope alone is going to be the glass to wall ratio. I did the math. It's like an 82% window to wall ratio. All they think they're doing all storefront glass. I'm like, you are not doing storefront glass here. Well, first off, you can't. And she said, oh, it's on agricultural land, so we don't have to meet codes. I'm like, what are you talking about? It's like, you don't have a permit, but you still have to meet codes.
Right.
So the last thing I said, if I never talk to you guys again, you have to meet code. Someone's going to get hurt and someone's going to get sued, and it's going to be a problem. And it's going to be a fun conversation. I should almost feel like I want to record the conversation when I talk to the architect from Amsterdam and the homeowner about what it means. But that envelope is already difficult before we have the conversation about what the reality is. So we're going to have to convert. The plans are done. I'm going to have to convert everything.
Wow.
So it's going to be an interesting arrangement.
I have a real estate brokerage license that I've had for 20 something years. And one of the things that they talk to real estate brokers about, and I come across this every year in my CE classes that I have to take, is they talk about competency in the area in which you live. So, like, I could get sued if I were to try to go sell a house in El Paso.
Yeah.
Because I don't know the El Paso market. So you're doing your client a disservice by trying to do something in an area in which you're not qualified, right?
Mm-hmm.
So I don't know the El Paso market. I don't know what houses cost. I don't know anything about the neighborhoods, the schools, yada yada yada. So I shouldn't practice real estate in El Paso. I know Houston, Texas.
Yeah.
As a standard of care for clients, it's probably a good idea for architects to have the same mentality. And there may be some architects that are well versed in different climate zones, but like I would not suggest that an architect from Houston try to design a house in Breckenridge or in Cashiers, North Carolina, or in Minnesota, and vice versa, or Amsterdam.
Yep.
Because they're not familiar with maybe the codes, the building, the climate zone. I mean, I can't imagine an architect in the Netherlands is familiar with U.S. energy code.
No.
And so, you're doing a disservice to your clients by even undertaking that type of project. I think they'd be better off partnering with a local architect and saying, hey, we're going to cast the vision for the property. Maybe here's some sketches. Here's the concept for the house. Let's work with somebody local to help us to design that.
I don't know how this Houston homeowner, ended up with this architect. Like I want to ask that, like, how did this occur? And when we have worked with a really, really awesome architectural firm out of Mexico City, and they design stuff that's here in Texas. And when they do, they always call us up and they say, hey, we got a project in Austin. Who is an architect that we can work with to fulfill it? We're going to only give you the imagery of it, what we would like to do. And we would like to be part of it, but we don't need to. They're smart enough to know they don't understand the difference between high elevation Mexico City and all of the areas in Texas. And they've delivered some beautiful, absolutely gorgeous projects. But like the one in Amsterdam, on top of that, I'm looking at this project. I could show you the project right now and I could write on a Post-it note what I think it's going to cost to build it. And then I would have you look at it and you write it on a Post-it note and we flip it over. And we would see, in fact, what we'll do is I'm not going to say how much I would say, and I'm going to share it with you. And then I'm going to tell you what I think it's going to cost to build. And you're going to tell me what you think it's going to cost to build. And then we'll share it on YouTube.
Okay.
We'll put it on there. Like, okay, what we think this is going to cost to build. I can tell you right now, the budget they have is nowhere near. And then I'll flip over what their budget's going to be.
Yeah.
Right. But I can't show the pictures online of the plans because I don't have permission for that.
Okay.
So, but we'll call it our Netherland guess. Right. And we do that a lot of times. You'll hear me say, hey, you want to put an over under on how much this house is going to cost to build? And we'll take little side bets on that, especially when there's projects we're not involved with.
Yeah.
But to go back to our, we talked about the wall. Before we finish this podcast, I want to speak about the foundation and the roof too.
Oh yeah.
The roof is a little bit different. We have a lot of convection wind that comes across it, and air blows across the ground, upside the house, over the top. So we have a convection airflow pattern. So it changes things thermodynamically. Also, we have a lot of the roofing, because of energy code, has what's called the solar reflective index standard. Now, they did that with an effort to try to lower utility bills, but that SRI actually helps me out a lot in terms of performance, because there's a thing called the heat halo, or the first 18 inches off the roof. And the higher the solar reflective index, the more heat is reflected off of it. And it basically builds the same thing that we have where all of our streets and buildings reflect all this heat and it builds a plume over it. It's the exact same thing as happening at a roof. So I have a lower rate of moisture introduction at the roof line. We do have to worry about heat and heat transfer coming in, meeting cold. Then we have moisture due to conductivity on a vapor barrier. So the roof is a little less of an issue until you get to a flat roof, and then it's like a wall. The foundation is really not much of an issue until you get to a pier and beam, right? But the great thing about foundation, it's all in the shade, right? That's the coolest foundation for us.
Mm-hmm.
And if I have space, I can get in there and build an integral air, water, vapor, pressure, thermal barrier on the outside, and I can be very successful with it because there's no cladding, right? There's no brick that's going to go on top of that. So I can do a down and dirty, ugly thing for it. Slabs are a little bit different. I have a client right now who wanted to put water heating in their slab to keep it warm. And I'm like, to keep it warm in the winter time? It's like, our slab does have, it's not really, really cold. He's like, well, and he wanted to do he just spec'd out the entire house. He's like, I just hate getting out of my bath and having cold floors. I'm like, whoa, slow down, man. Let's just put some heating
in your bathroom.
Let's do that Schluter heating system. That's really cool. In your bathroom. Let's call it a day. But we have clients that would complain when they do marble on a slab and they have these really, really large houses where the radiant sun doesn't heat up the floor and they're cold in the wintertime.
Yeah.
Most of the time you're one Ugg boot away from fixing that problem, right? Older slabs are a little bit different. And our slab performance is not going to be as long in terms of durability as it used to be.
Yeah, I mean, we've seen a lot of problems with older slabs that maybe didn't have a moisture barrier under the slab, or they had a compromised moisture barrier. And so then we start seeing things like issues with hardwood floors, mold and mildew in
cabinets, toe kicks
and closets.
Yep.
All that kind of stuff.
Yeah. And that's tricky because when you go do the indoor air testing on that, it's not going to produce a failure on your indoor air test because it's low levels of mycotoxins spread across a very, very, very large area. So you'll get really, really low counts of like Chaetotorium or Cladosporium molds. But if I was to actually pull up that flooring, I could prove that it's there. And the challenge is you're actually intaking that mold spore, not just through the breathable environment, but also through contact. And at what age are you in the most contact with the floor barefoot?
I mean, I would say when you're a kid.
There you are. You're right.
Babies, toddlers.
Yeah. Right. And so it is a very common thing for us to only be in those houses when parents are concerned about the developmental issues with their children, to get their children tested. They have high counts of mold. I go to the house. It's a memorial house built in the 1960s with engineered wood floors or laminate wood floors or porcelain floors. And the kids are scooting around on Cladosporium mold. Mm-hmm. That's a rough little conversation to have.
Yeah. So since this is kind of about failures, I mean, again, what we've come across is when you do a remodel in a lot of these houses. Well, first of all, most of the houses that were built on slabs, like in this memorial neighborhood of Houston back in the day, like the original hardwoods were sitting on screeds. So you had a layer of tar that's essentially sealing that slab. And then you've got 1x4s and then your wood plank floors on top of that, right? So that tar is kind of creating a barrier. And then you also have like an air gap in there in between the floors and the slab as well. But oftentimes in the remodels now, because your people have done additions over the years, and maybe your floors are different heights, they'll come in and want to level it and then put the same floor everywhere. So they'll tear it all out and they'll go back with engineered hardwoods or LVP or porcelain tile. And that's when the issues start to present themselves.
Well, and also during that remodel, we change out the windows. So we've changed the dynamics. So that leakage rate has been lessened. We changed out the AC system. It's going to blow colder than it used to at a higher pressure rate. So now I still, and they didn't resize it because they didn't address the insulation. So I still have that high pressure system, that positive pressure system, but I don't have positive leakage anymore. So that's going to change the temperature of the surfaces on the interior, including the floor, which is going to make them colder, which is going to change the thermodynamics, which is going to increase the vapor drive, which will increase the condensation. And there we are. So you have to think through it entirely.
Yeah.
So like that, a buddy of yours is about to do a remodel. I know it's just a make pretty, but I would love to still go buy that house and just double check, because we just see things that no one else sees.
Yeah.
And part of that make pretty may be his flooring.
Yep.
Right. And I want to have that conversation with him and understand what we're doing. Another aspect about those old floors is I'll take old growth oak all day long. 2 1/4 inch shorty oak is a very hard, dense, wide grain format. But in the South, we don't want to do wide plank. You go take a piece of pine 4 inches wide, it's going to cup 10%. Naturally, you'll see that 10% cup. Mm-hmm. The 2 1/4 inch oak, it's going to cup about 3%, but 3% of 2 1/4 inches is almost non-discernible.
Right.
Right. But people thankfully, I feel like the wide plank thing is kind of calmed down.
Yeah.
A little bit.
I feel it was like constantly pushing the envelope on how wide can you make the planks.
I get the joke.
Yeah. pushing the envelope. I don't think about that. Yeah, I mean, it's like, at first the 2¼ inch floors are fine. Then it's 5 inch, then 7, then 9. 12-inch wide oak planks. Holy crap!
Yep.
Why are the ends bowed up a 1/2 inch on each side of the plank?
It's like little ski parks everywhere, or skate parks everywhere, because it's like just all these. And then they'll come in and sand them down, thinking it's a wood insulation problem, and they'll reverse in the wintertime when we have convex in the wintertime. So that's probably one of the most disappointing things I have to tell a client when we have an issue like that is like, on your wood floors, we're going to fix everything, and you have to wait 18 months, 6 seasons before we even think about refinishing your floors. Because there's a good chance the wood floors have memory. They'll go back into the position. But new growth wood floors are not the same as old growth wood floors.
They've grown faster, generally speaking.
Faster, yeah. They're younger when they're cut. Is really the thing. We could have a whole conversation on just wood flooring.
Actually, yeah, I have a flooring performance episode that I want to do sometime in the near future. So we'll come back and talk about that for sure.
That'd be great.
Get a flooring guy on with us.
I have an attorney who sues flooring problems that we can bring him on.
Perfect.
Yeah, that'd be great. We've not had an attorney on the podcast in a while, but it's kind of in fact, I even helped my sister in Dallas settle a resilient flooring claim. She has not paid her invoice. I've got to get with her. So
if you're listening, pay your bill.
Pay your bill.
All right. Well, I think we're going to wrap it up for today. Appreciate you being back on as always. And if you're listening and you want any more information on these building performance, building envelope issues, please reach out to Toner, myself. We'll get you hooked up with one of us or the right person. If we're not the right person for you in your market, we can point you in the right direction. So
and I want to reiterate on that. Both you and I do the same thing, that we don't charge for a phone call, right? If you want to jump on Zoom and discuss what's going on, you and I are both believers in big believers in business karma. If we can't help you, but we can help you along, that's a win for us.
Yeah, exactly.
So please, folks, don't be afraid to give us a shout. We're here to help.
Absolutely. So thanks for joining us on the Your Project Shepherd podcast today, and we'll see you next time.
Let me show you the picture of the house.
Okay.
I'm going to write how much I think the house is going to cost.
Okay.
You're going to write how much you think the house is going to cost. All right. So I'm going to open up this plan.
Okay.
I'm going to let you look at it for 1 minute. Okay. And let you scroll through it. Let's make sure I can even open this thing up. And the idea is, now this is in, I kind of explained where it was. Okay. So you can go ahead and start scrolling through it and zoom in.
I'll let you.
Okay.
You take that first. I won't look.
I'm going to tell you.
I'm going to scroll.
I'm going to stay within a $250,000 range. Okay. So don't say, if you put $1 on this, and it's not who goes over, it's not Price is Right. Right.
Okay.
So
I'm trying to find a table that's got like all the square footages and everything on there.
I'm going to tell you.
Is that on there? I assume.
No. If it is, I've missed it. I just haven't looked at it. I've had these plans for all of 36 hours.
Oh, okay.
So I'm going to take into account the fact that this is out of town. It's not near a metropolitan area. It's going to be an extremely difficult structure. This is my rationale. I'd like you to hear your rationale behind before you write your pricing down.
Okay.
High window to wall ratio, ultra mod, which is uncommon. I'm not taking into account design fees. That's outside of this. And I'm not going to take into account any of the implements necessary for living on land, gates and roads, because the driveway could be monstrous. I'm just going to talk about the physical structure construction.
Right. Yep. Got it.
I'm going to say, and conservatively to build it, it's not a huge structure. It's not, 8,000 square feet.
Mm-mm.
It doesn't have a lot of outside space. It is minimalistic, at least in some of the interior, acronym. So I'm going to put,
I wish the square footage was on here. Yep. At least there's some good 3D renderings of it, right?
All right.
How far is Fayetteville Drive from here, roughly?
Now we're trying not to lay out too much information about this house in particular.
Oh, sure.
So,
well, you said it. You said the city a while ago.
Okay.
So,
It is.
What's that, about an hour and a half from here? Yes, I don't see any square footage anywhere, but it doesn't look that big.
It's not that big. I think it's only a 3-bedroom.
I mean, I was going to guess the AC square footage of the house is only 2,000 square feet.
I think
maybe.
it's maybe 2,100 square feet. I think it's less than 2,500 square feet.
And then the garage is what, a 3-car garage, detached.
Yep, but not barn style. It's a regular, like, in-town house.
But then there's also like a storage room off the garage as well. So it's a pretty good sized garage. It looks like about 30 by 40 garage structure. Okay.
Now, just because you're a builder out in Fayetteville, that doesn't mean that you're cheaper than a builder in Houston. And I think that's a misconception for a lot of our clients.
Oh, right.
Because they have a lower rate of projects, so their efficiencies of scale are less. And all the trades are more scarce, and good ones especially.
Well, I was about to say, like, good luck finding the right trades.
So are you going to have to bring in trades from
Houston, Austin, whatever?
The problem is with Fayetteville, they get a lot of influence from Austin, and Austin trades are already 30% more than every Houston trade.
Mm-hmm.
So if you're going to bring in trades, you need to bring them from Houston, but the builder may not know that. And I can already think of 3 awesome builders to refer to them that we've already gone through this stuff with. And they are not Houston builders, although I can think of another 3 Houston builders that will travel out there. That gets really expensive.
God, there's so much glass on this thing. I mean.
Yep. And that's spec'd with storefront glass, knowing I'm going to have to go back to assembled glass. So the glass budget alone on this is going to be monstrous.
Oh, yeah.
Yep. And they want the frame of the glass, the bottom frame of the glass, to be recessed into the slab.
Ooh. All right. I got to pull my calculator out.
Oh my gosh. I just went off my gut. Now you price houses for a living, so.
Let's see. Actually, let's see.
This is where you play the dun, 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 dun. And I'm looking at the pictures here. All of the people they put in the pictures are extremely good looking. So you know that's going to be.
My photos in there?
You see that cut sheet of that roof?
All right, I'm going to hold mine up to
not going to look
to the camera here. Did you get it?
All right. So you want me to go first? Because I think you might be a little more accurate than me. So I think based on the fact that it's out of town, high weight of window to wall ratio, the amount of slab, because that extended slab all the way out, a lot of covered porch, the assembly, the flat roof. I said at least 225, $2,250,000. Oh my gosh, you're $1 million more than me.
So I just based that on.
You did a square foot price, didn't you?
Well, I said as a guideline, yeah. So I said if the house is 2,100 square feet, plus you've got some covered porches that also should count as
square footage,
covered square footage, because you've got a wood ceiling and probably a lot of nice outdoor finishes, plus the square footage of the garage. So I took kind of all that covered square footage, and I just put a $800 something a foot on there to build that.
Okay. You want to know what their proposed budget for the entire build is right now?
I'm going to guess probably 1.4.
1.2.
There you go.
I'm $1 million off. You're $2 million off of that. I mean, it's not an easy build. It's not that much square footage, but it is beautiful. Like, it's cool looking. But even that roof, that floating extended flat roof, which is not exactly flat. It's got like a 212 pitch on it, right? But they want to see that cladding come from the ceiling through the window glass. They're going to extend the top of the window up into that so that it's just glass to glass extending out. But the AC is designed to run on the outside of that. So my envelope goes slab, glass across the ceiling, and they're using finished wood materials, then up this short fascia, then back across this long roof. And I've got to be able to seal that all equally. So I need, just in the depth of the ceiling, I'm going to need about 6 inches. But the total height from the finished, from the flat roof element to the finished ceiling cladding is only 16 inches.
Yikes.
And the amount of air. So I already know, but
truss system for the roof.
Truss system for the roof, but they have so much metal that's going to transgress that it doesn't matter anyways.
Oh yeah.
And their depth is only 18 inches. I'm going to have the spans. They're going to have, where's call Matt. I'm going to have 20-inch deep. I'm going to have 24-inch deep steel in some places.
I priced one very similar to this in, I want to say Sweeney, Texas.
Yeah.
About 2 years ago by a prominent Houston mid-century style architect who we know. And same deal. The guy came to me, and it was smaller than this. The guy said he had a $800,000 budget to build it. And again, it was smaller than this. It had no garage actually. And it was over 2 million, when I priced that out, and he shelved the project. He's like, it doesn't make sense building that in Sweeney, Texas.
Yep. What we need to do is we need to get 4 sheeters, get 4 plans with just 4 sheeters. So elevations, first floor, second floor, and then 1 cut sheet, and get Matt Sneller in here, you, me, and like Deitcher. And we need to know how much that house was actually built for, which you will have. You'll have the actual price. And it comes up on screen, and we get to all look at it, and we all make our guesses and lay it down, and then you tell us how much it was.
I like that game.
Right? Like we should add it to the last season of How Much Do Things Cost as a bonus one. That'd be a fun game to have.
Actually, I think it'd be good to to throw an architect in the mix on that, because it's always interesting to
throw
see
McFarland on it.
It's interesting to see what architects think things cost too.
Well, and that would be interesting because I'm on the design side. Jeremy McFarland with Brick Moon will be on the design side. Of course, the 2 or 3 of y'all will be on the build side.
Yeah.
But I think that will be a fun bonus feature to the whole season on how much do things cost. Right.
We'll push the limits of our studio, and we'll turn the table. We'll have like 5 people here, and we'll push Daniela's limits on running the board back there.
Well, that's where we almost need to put the TV up there so everyone can see it. But you could put it back up. What we're looking at, you'd be able to put it onto what they're viewing.
Yeah.
That'd almost be a YouTube only one.
It's actually wired for a TV behind that sign.
Oh, is it?
Yeah,
we have that there. But I could see that being, because I wanted to say 3, but I'm like, okay, they're probably going to make a bunch of concessions here. Like, there's no way.
I mean, as it is, it's probably 3, but I mean, you add in all the road work and everything else. Dude,
this is a $5 million
It's going to be 4 to 5. Yeah.
I mean, and the challenge is it's a family ranch of about 600 acres. So there's like 4 other family members there, and they all don't want them building this modern style structure on it. So there's already family infighting over it. And she's like, well, this is my section of the ranch. I can do anything I want with it.
Wow.
So they don't have what they do for a living does not produce this kind of coin, but they could have family money,
you never know.
We never know. So
all right, there we go.